Okay. Now this is going to be new. There we go. And here's what you need. This is an example of what we're going to be doing today, so you need to write this down. A to the m over n power. We're doing rational exponents, which means fractions. We're going to be dealing with fractions. Nothing, it's not that hard. Now, rational exponents can be changed to radical form. And all you have to remember is this. The bottom of the fraction, the denominator, is the root. So n stands for any root. Remember, where does the root have to go? Inside the check mark. How many of you remember missing problems because you didn't write the number in the correct place? It goes inside the check mark. Do you see this is on the bottom, isn't it? It's called a root. Where are the roots of a tree? On the bottom. That helps you remember. The root is always on the bottom. Now the top is the power, the exponent. So the a goes in here. We're taking the nth root of a and then to the power of m. Does that make sense? It's just a definition. Well, why are you not changing? Interesting. Now, here's what you're doing today. You're going both directions. First thing we're going to do is go to the root and simplify. Then on the last part of your assignment, we're going to go from radical form back to exponential. So this is exponential, this is radical. Exponential and radical. Okay. So, what is 9 to the 1/2 the same as in radical form? Wouldn't that just be the square root of 9? Isn't 2 a square root? Right? Now anything to the first power is still the same thing, isn't it? We could write this, but do we need to? Does anything to the first power change anything? No. So now we have the square root of 9, which is, and there's my final answer. Let's go to number 2. Change that, at least rewrite it, number 2, in radical form. Write it in radical form. Then you simplify like we did about a week ago. Okay, let's just write it first. What's the root on this one? Cube. Start using the math language. This is a cube root, right? Of 27 raised to the 4th power. Did you listen how I said that? If you were talking to me, you should say the same thing when you're talking about these things. Learn the math vocabulary. Now, how many have an answer to this already? Okay. What'd you get? 12. No. And I know what you did. Brooke? 81. Yes. How many got 81? Well, here it is. What's the cube root of 27? You all did this. You should know how to do this. We did this, we did this, we did this over and over and over. Learned how to do this last week. Isn't there a cube root of 27? 3 times 3 times 3? So 3 is the cube root. And now isn't it still raised to what power? Now that's not 3 times 4. What does it mean to take it to the 4th power? 3 times 3 times 3 times 3, which is 81. Well, this case 3. We're still doing the same simplifying. Then you take it to that power. You mean if it doesn't come out even? I don't think I gave you any of those yet. I think we're going to stay with the ones that come out even. I just want you to be able to work with it right now. Let's look at number 3 and see what it looks like. That one's easy. You've got 5 seconds to write that answer. 1, 2, 3, 4, 5. Time's up. What's the answer? 6. Thank you. Give yourself a bonus point. Now here's something you ought to pick up real quick. If there are no numbers higher than 1 for the power, so anything to the 1/2 power is just square root, isn't it? How about anything to 1/3? Cube root. How about anything to the 1/4? 4th root. Are you following me? So if there's a 1 on top, you don't have to worry about the power because anything to the 1st power doesn't change anything. Have you got that locked in? Okay. Let's go to number 4. Do that one for me. This one is going to be a negative. It's got a negative, don't say it out loud, it has a negative exponent, but you still treat it. You still got to change it, but you also got to do something else to make it a positive exponent, and I would do that first. Let's see if we got any thinkers in here. From yesterday, you learned this stuff the other day. Let's see if you did the first step right. This is what you should have done first. How do we make a negative exponent positive? You move it. This is over 1. And you can't do anything, you can't do the other thing to it yet. Anyway, not till you get rid of the negative. Beg your pardon? Doesn't matter. It's the exponent is negative, you move it. No? It's a negative out in front. How many did this first? Okay, I didn't know if everybody would know to do that, but you have to do that first. Now we rewrite it as a radical, so what kind of root is this? Square root of 81 to the 3rd power. Which is 1 over 9 to the 3rd, which is 1 over what? 729? Yes. Now, did anybody get there before me? I'm going to give you 2 for this one. Because that one I didn't talk too much about doing that yet. So, all right, now let's do number 5. Number 5 is very similar. Got a negative exponent. I'm sorry, you having trouble seeing it? Yeah. Let me do this then. I can make it bigger. I have the power. Is that big enough? I can make it bigger. And then just a little bit bigger. What were we laughing about? All right. How many haven't answered? Who said I do? Well, let's do this first. Is this a square root, isn't it? And that's going to be 1 over. How many have 1/8 for this? Yeah, give yourself a bonus point. Do number 5 now, or number, what was that? That's 5. Can't even see it. Should be able to see it, huh? Now, what does it say to do in this one? Oh, we got. You're supposed to know how to do variables. Remember, we've done this before. First, rewrite it in radical form. That's exponential, write it in radical. Now, when it has a parentheses around it, everything in the parentheses goes inside the radical. Did you follow me there? Everything in the parentheses goes inside the radical. It's pretty radical. Okay. So when we rewrite this, what do we get? Square root of x to the 4th raised to the 3rd, like that. Now, how do you take the square root when you have an exponent? Yes, you divide by the root. Since this is a square root, that's like a 2. How many times does 2 go into this? So this equals x to the 2nd raised to the 3rd. And then this is an exponential law we talked about yesterday. What do we do with exponents here? Multiply. So your final answer is yes. How many got that right? Excellent. Give yourself a bonus point. Let's go to number 7. We're going to work all 12. Do I have 12 problems? Oh, you don't have the paper, do you? Sorry about that. Yeah. Well, do number 7. Write it down. I'm going to check and see how many problems I got after you write this down. Yeah, Mr. Milburn wants us to save papers, so we're trying to not print out as many papers. I guess some teachers are running off books of stuff. Do you ever get classes where you get PowerPoints stapled, a whole packet? Well, they need to stop doing that. They're the reason why they're going to start telling us we can't do but so much paper. Why would you hand out a PowerPoint when you're going to show a PowerPoint that looks just like a PowerPoint? I don't get the point. All right. You didn't get the joke, did you? All right. So what do we got here? Well, this is easy. There's no power to this one. There is, but it's 1. Aren't we just doing the square root of this? Isn't it just 8n to the 3rd? How many had 8n to the 3rd? The rest of you see why. What's the square root of 64? Doesn't this mean square root? Remember I talked about it earlier. And what do you do to get this? Now I'm going to show you something. What's the power or the root on the 64 if there was an exponent? It'd be a 1, wouldn't it? Well, this is the power where you would have 1/2 times 1 is 1/2. What's 1/2 times 6? 3, isn't it? No. Yeah, half of 6 is 3. Now, all I did was the power to a power. Thanks. Haley, it's for you when it says when convenient, so we'll wait. So now, don't you have the square root of this is 8 and n to the 3rd? There's 2 ways to look at this, but that's your final answer on that one. I'm going to give you 2 for that one. I'm going to see how many problems I have. 8, 9, 10, 11. Oh, baby. Getting there. Oh, we got 15. Yeah. We got time. So we just did number what? All right, do number 8 now. This one has a power on it. I mean a power other than 1. Okay, let's write it in radical form, which would be the cube root of 64 raised to the 5th. Oh, thank you. And to the 6th. Didn't see that. Yeah, everything in the parentheses goes underneath the radical. Well, you can just do one thing at a time. Now, I'm good at this because I've been doing this for a long time. But I knew right off the bat that there's a number, and you can think that way on this assignment because I've given you perfect cubes and perfect squares and perfect fourths. What is the number times itself 3 times that gives you 64? How many figured that out without doing the factoring? See, pretty soon you should be able to do that. Or you can try them. If it ends in 4, think about it. 4 times 4 is 16. Times 4, 64. So the cube root of that is 4. How do we do the cube root of an exponent n to the 6th? You divide by 3, don't you? How many times does 3 go into 6? None left over, are there? So everything in here had a perfect cube root. But now all of this is raised to what power? Let's see if you knew how to finish this. Remember I told you that this has its own exponent. This is the power to the power. What do we do with exponents when you have a power to the power? Multiply. That's your exponential property or law. So this is really the same as 4 to the 5th n to the what? 10th. Now you need to figure out 4 to the 5th. 1024? N to the 10th, yes. There it is. Anybody get that before I got there? Excellent. Give yourself 1, because I'm giving away too many points today. All right, well, how much time we got left? About 6 minutes? 5 minutes?
Not enough.
Okay. You just love being in here, don't you?
No.
You said not enough. Now, this thing's driving me crazy. Let's go to this one now. We're going to go, all we're asking you to do is write it in radical form. Is that what the last, oh, you don't have this paper, I forgot. Let's see what else I got. This is 11 and 12. I think that's all we got left. Let's just finish these two. We're doing the same thing on all of these. Finish 9, do that one. Which one was the last one we did, number 8? Yeah, do number 9. So that in radical form is what? Raised to the 3rd. So that is the same as x to the what? 3rd raised to the 3rd. So the final answer is, how many got that right? 1 bonus point. Now, we're going to do a couple of others and then we'll be finished. I don't need to do all 15 of these. Here's what I want you to do. I guess I've already done all that. I don't have any of these on here, do I? I was hoping to have some in radical form where you could go in the reverse. Let's just make up a couple. You need to do this because it's on your homework. I'll just make up a couple problems here. All right, let's say you have rewrite that in exponential. Now we're going in reverse. You're not simplifying anything. I want it written in exponential. We're going backwards. Is it tough to go in reverse? Okay, name the months of the year in reverse. How come you can't go as fast as the other way? Okay, stop. All right. What is this in exponential? 6x squared, but you got to do this. Remember, whatever's inside the radical was in parentheses, wasn't it? What's this exponent? Right. How many did that? So you don't need any more of those? No. All right, you can say the months of the year: January, February, March, April, May, June, July, August, September, October. You can do that real fast. How come you can't do the other one fast? All right. Do you want your assignment today or tomorrow? I hear mixed confusion.